Hello friends, welcome back. Hearty welcome to you. Let's try to find out the domain and range of this given function in this particular session. We have been given f of x is equal to x square plus x plus 2 divided by x square plus 2x plus 4. We have to find out the domain and the range of this function. First, let's try to understand what is the domain of this function. Domain, we know that the only constraint is here, the denominator should not be equal to 0. So x square plus 2x plus 4 should not be equal to 0. So if I have any values for which the denominator will become 0, then those values should be excluded from the real numbers, because from numerator side I don't have any issues. Only the thing is denominator should not be equal to 0. Now let us try to find out, is there any x values for which the x square plus 2x plus 4 will be equal to 0. Now the zeros of this equation, x square plus 2x plus 4 equal to 0, is given by quadratic formula minus b plus or minus square root of b square minus 4ac divided by 2a. So can I write down minus 2 plus or minus b plus or minus? What's our a here? A is 1. What's the b value? 2. What is c? 4. What is the formula we are using? Minus b plus or minus square root of b square minus 4ac divided by 2a. Or can I check directly whether the discriminant is less than 0 or greater than or equal to 0? That is also fine. B square is 4 minus 4 into 1 into 4 divided by 2a, that's equal to 2. And we see that in square root we have negative value there, because 4 minus 16 is minus 12. We know that if discriminant is less than 0, then we know that the roots are imaginary. If the roots are imaginary, the meaning is that all real values are allowed to the domain. So let me repeat that. We have the denominator should not be equal to 0. So I have to find out any values of x which will make the denominator 0. I found nothing because the roots are imaginary, as the discriminant of this quadratic equation is less than 0. So let's go to range now. We'll try to find out what is the range of this. To find out the range, we can do couple of approaches. The one approach we can do is we can equate y equal to x square plus x plus 2 divided by x square plus 2x plus 4, then try to find out the x value in terms of y, and then switch x and y so that we go to the domain of the inverse function and try to find out from the domain what values can be given to that particular function so that the function is definable. That's a one way which we have seen in last examples. Now in this example we'll try to go another approach, that is, we know that the domain is real numbers, all real numbers are allowed. So let us try to get a quadratic equation in x here, and we know that the roots should be greater than or equal to 0. The discriminant should be greater than or equal to 0 if the roots are real. So let's first try to get a quadratic equation here. I just take y and multiply. I get x square y plus 2xy plus 4y equal to x square plus x plus 2. Now let's simplify this. We have x square into y minus 1 plus x into 2y minus 1 plus 4y minus 2. Can I write it as 2 into 2y minus 1? This should be greater than or equal to 0. So we know that in this particular quadratic equation our a is y minus 1, our b is 2y minus 1, and your c is 2 into 2y minus 1. We know that b square minus 4ac should be greater than or equal to 0. So let's go ahead and substitute the values. We have 2y minus 1 whole square, that is our b square, minus 4 into a, that is y minus 1, into c, that is 2 into 2y minus 1, should be greater than or equal to 0. Let's simplify this. So I see that 2y minus 1 is common. So why can't I take 2y minus 1 out? If I take 2y minus 1 out, I am left out here with 2y minus 1 minus of 4 2's are 8. 8 into y minus 1 should be greater than or equal to 0. So can I say 2y minus 1 into 2y minus 1 minus 8y plus 8 should be greater than or equal to 0, or can I simplify and say 2y minus 1 into 7 minus 6y should be greater than or equal to 0. Now we try to find out the values of y which will satisfy this particular equation. So let's go to the number line minus infinity to infinity. Let's divide this into what are the critical points here. 2y equal to 1, y equal to 1 by 2. Let us say 1 by 2 is 1 point. 7 equal to or y equal to 7 by 6, that is 1 point something around 1.16, that is 7 by 6. Now first, as usual, we always check for y equal to 0. If I put y equal to 0, this becomes minus 1 multiply with 7, which is minus 7 greater than or equal to 0 is wrong. That means the interval in which 0 is there, that interval is false. This interval is false. Obviously the next one will be true and the next one will be false. So the values which can be given now is nothing but equal to 1 by 2 and 7 by 6, which will satisfy this equation, that 1 by 2 comma 7 by 6. The values which are there between 1 by 2 and 7 by 6 will satisfy that 2y minus 1 into 7 minus 6y greater than or equal to 0. That means the range of the function is the values between 1 by 2 to 7 by 6. The range will be between 1 by 2 to 7 by 6, including the boundaries. That's how we can find out the domain and range of a function, which is like where in the denominator you cannot factorize it, but but sometimes you can apply quadratic formula and find out whether any real roots are existing or not existing. Then to find out the range, we equate to y, we do cross multiplication, we get a quadratic formula in x, and we know that x value should be real. So we can say discriminant is greater than or equal to 0, or b square minus 4ac greater than or equal to 0, by which we should be able to easily find out what will be the range of a function. So let's solve another example of the same type where the denominator is, let's say, instead of x square plus 2x plus 4, x square minus 3x minus 6 in the next session. Thanks for your time and support. Bye for now.